Welcome to the class again. We were discussing Grignard reagents. We have just completed the preparation of Grignard reagent. Now, ether solvent is the best for the generation of Grignard reagents. Why? Ether solvent stabilizes Grignard reagents by forming a Lewis acid Lewis base complex like this. So ether solvent stabilizes Grignard reagents. So that is why generally we use ether as the solvent. Now when we look at the Grignard reagent, how it exists in the reaction mixture or in its structure. Generally, Grignard reagent will exist as a dimer. It will not exist as a single molecule. It exists as a dimer. How it exists as a dimer? Grignard reagent, two molecules of Grignard reagent is generally in equilibrium with dialkyl magnesium and magnesium halide, or it will be in equilibrium a complex of dialkyl magnesium and magnesium halide. So it is a dimer. Grignard reagent is a dimer. It is not a single molecule. This is called Schlenk equilibrium. This is called Schlenk equilibrium. We can also draw the structures for dimer conformation. Magnesium electropositive element, halide electronegative element. So they may have Lewis acid Lewis base interaction or coordination interaction. So it will exist as a dimer either in this form or in this form. Please take the notes. Not only dimer, monomeric form, monomeric RMGX exists in triethyl amine solvent. Generally in ether it exists as a dimer, but in triethylamine it exists as a monomer. Now we will look at the formation of Grignard reagents with alkyl halides. Generally, alkyl iodides will easily generate Grignard reagents. Then alkyl bromides, then alkyl chlorides, and least reactive in Grignard generations is alkyl fluorides. Generally, we don't observe Grignard formation with alkyl fluorides. It is mostly because of the longer bond lengths and more polarizations. When we look at the alkyl groups, simple alkyl groups will undergo Grignard formation easily compared to bulky alkyl groups. Then N-propyl halide. When we look at the complete list of alkyl groups, allyl benzyl halides they are more fast in generating, or they are more reactive in generating Grignard reagents than primary alkyl group, secondary alkyl group, tertiary alkyl halides. And the least reactive is vinyl aryl halides. Least reactive is vinyl aryl halides. Of course, we can understand this because in vinyl and aryl, carbon is sp2 hybridized. So the bond length is small compared to normal alkyl halides. So it is less polarized compared to these. So that is why generally we use THF as the solvent when we want to prepare phenyl Grignard reagent or vinyl Grignard reagent. Why do we use THF? THF is more basic in nature compared to ether. So it facilitates the formation of even difficult Grignard reagents. Similarly, here also we will use THF as the solvent to generate vinyl Grignard reagents. When we look at the comparison, in this alkyl dihalide, we have both iodine and chlorine. Then when we want to generate Grignard reagent, which halogen will preferentially involve in Grignard reagent formation? Yeah, from the reactivity order, it is the iodine which will generally have high reactivity towards Grignard generation. So when we want to have selective Grignard generation among different halogens, iodine will be very reactive, then bromine, then chlorine. Of course, here also we can generate Grignard reagent, or it will undergo a nucleophilic reaction. Grignard reagents are commercially available, but we can also prepare some of the Grignard reagents in the lab itself. So we don't need to buy. Generally, allyl Grignard is prepared in the lab. So whenever we want, we can prepare and we can store it, allyl Grignard. Similarly, Estelini Grignards, these can be prepared in situ. Most of the time, either ether or THF is used as the solvent for Grignard reagents. This proton is acidic in nature because negative charge on triple bond carbon is stable. So this is acidic in nature. So compounds having acidic proton, they can be easily removed with Grignard reagents because Grignard reagent can act as a base. So ethyl anion will pick up this proton. So we are generating MgBr plus ethane gas. What is ethane? Ethane is a gas, so it will escape from the reaction mixture. So what we have is acetylene Grignard. So the compounds with acidic proton, their Grignard reagents can be prepared in situ. So whenever we want to use this reagent, what we can do, first we will mix acetylene and Grignard reagent, some simple Grignard reagent. So it will generate that acetylene Grignard. This will be escaping. So these can be prepared in situ. Here also, when we take out this proton, it becomes aromatic nature. That means this proton is acidic in nature, so which can be easily removed. Here also this cyclopentadienyl Grignard reagent can be easily prepared. So vinyl Grignard and these Grignards which are having acidic protons, they can be prepared in the laboratory. All other Grignard reagents are commercially available. So whenever we want to buy them, whenever we want to use them, we can buy them. So they are all commercially available. Please take the notes simultaneously. When we look at the reactivity of Grignard reagents, Grignard reagents act as both as a base as well as a nucleophile. Grignard reagents act as a base as well as a nucleophile. Why? Because Grignard reagents, the alkyl group is negatively charged. Negatively charged alkyl group, carbanion. Carbanions can act as a base as well as a nucleophile. First, we will look at the reactivity of Grignard reagent as a base. When we use water, Grignard reagent act as a base. So R minus will pick up a proton from water. So it becomes RH, alkane. So when we add water, Grignard reagents will pick up a proton from water, so they become alkane. That means the Grignard reagent will quench. And we also have MgXOH. Of course, this will further undergo hydrolysis. Another halogen will be leaving and it becomes magnesium hydroxide. Okay. When we use deuterated water, then alkyl anion will pick up that deuterated proton. So it becomes Rd. And of course, when we use alcohol, alcohol is having again an acidic proton. So here Grignard reagent act as a base and will pick up this acidic proton. It becomes alkane and magnesium will become magnesium oxide. So wherever we have an acidic proton, in case of phenol or in case of carboxylic acid or in case of amine or in case of amides, wherever we have an acidic proton, Grignard reagent acts as a base and will immediately pick up that proton. And similarly, we have estrylinic proton. Estrylinic proton is again an acidic proton. So whenever we have these acidic proton sources, Grignard reagent will act as a base and will pick up the proton. So you complete this table. Now we look at the reactivity of Grignard reagent as a nucleophile. How do we convert bromobenzene to benzene? It is simple. We can convert bromobenzene to phenyl grignard and then we add water so that it becomes benzene. When we add magnesium, it generates a Grignard reagent, phenyl magnesium bromide. Now, when we add water, it acts as a base, so it picks up the acidic proton and it will be converted to benzene. Similarly, how do we convert an alkyl halide to alkane? In this case, just for a variation, I am making it deuterium. You write the reagents. Now, when we treat Grignard reagents with carbon dioxide, Grignard reagent acts as a nucleophile and it will attack on carbon dioxide to generate carboxylic acid. How do we do this conversion? Grignard reagents are nucleophilic in nature. Here, carbon is positively charged, partially positively charged, oxygen is partially negatively charged. So R minus will attack on carbon, R minus will attack on carbon, then C double bond will be polarized towards oxygen. So the product is R, C, one double bond is there. Now this double bond is converted to single bond. So we are generating negative charge. And of course, this is the counter ion. Or MgX is the counter ion. And finally, when we add water or dilute acid, O minus will pick up the proton and it becomes carboxylic acid. Of course, magnesium halides will be hydrolyzed to magnesium oxides. Okay. Just take these practice problems. When we want to have only one type of Grignard reagent, which one will undergo Grignard reagent formation among iodine and chlorine? Then it is treated with carbon dioxide followed by dilute acid treatment. What is the product? What is the product here? When we have E double bond or Z double bond, E vinyl alkyl halide or Z vinyl halide, And when we want to generate a Grignard reagent with this, Grignard reagent generation is not stereoselective. It is not a stereoselective reaction. So whether the starting material is E or Z, it doesn't matter. The product will be a mixture of both E and Z. The product will be a mixture of both E and Z. So what we are getting, though we are starting the reaction with either E alkene or Z alkene, it doesn't matter. We will end up with a mixture of E and Z compounds, okay, because it is not a stereoselective reaction. What is the product? It is not a stereoselective reaction. Please take the notes. So Grignard generation is not a stereoselective reaction.